Characteristic properties of amino acids. They form zwitterions, an ion with a positive and negative charge but are electrically neutral. They have an isoelectric point at which they don't move in an electric field. They have a buffer action. They are amphoteric and therefore can react with small amounts of acids and bases to minimize the change in pH. Amino acids are amphoteric. As amino acids contain both an acid group, the carboxyl group, and a basic group, which is the amino group, they are able to react with both acids and bases. They are amphoteric. This equation here sees this zwitterion losing a proton or donating a proton, and the proton's over here, and the proton has come from this NH3 plus group, which is now NH2. This equation shows the zwitterion accepting this proton, okay, and it joins on this negative COO negative group here, and on the right side you can see we have a COOH group. So this is one way of writing equations to show that amino acids are amphoteric. We'll now look at another way. Here we have the zwitterion, and in this case the zwitterion is acting as a Bronsted-Lowry acid, and it's donating one of these hydrogens here to this OH negative, which is the Bronsted-Lowry base. Okay, on the right side we have an NH2 and we have the water molecule. Okay, on the bottom here we have the zwitterion, and this time we have the H3O plus, which is the hydronium ion. This is going to act as a Bronsted-Lowry acid, and the base, and the amino acid is acting as the Bronsted-Lowry base. So this H3O plus is going to donate a proton to the amino acid, and over here we can see the proton has joined to this oxygen, and then we have the water molecule. So this top equation shows the amino acid acting as a Bronsted-Lowry acid, and the bottom equation shows the amino acid acting as a Bronsted-Lowry base. So amino acids are amphoteric. Next we look at the isoelectric point. The pH determines the net charge the amino acid carries. It is positively charged at low pH and negatively charged at high pH. The pH at which the amino acid is electrically neutral is the isoelectric point. So here in the middle we have the zwitterion, we have the positive end and the negative end, but overall the molecule is electrically neutral. At low pH it's positively charged. At high pH it's negatively charged. Table 19 in the data booklet gives the pH of the isoelectric point of some amino acids. Here's an example: alanine, the symbol is ALA. Here's the structural formula. In this case the R group is a CH3, a methyl group, and the pH of the isoelectric point is 6.0. So let's look at an example. At pH 9.0, what will be the charge of alanine? And at pH 3.0, what will be the charge? Well, at pH 9.0, it'll be negatively charged because it's above the isoelectric point. At pH 3.0, it'll be positively charged because it's below the isoelectric point. And at pH 6.0, the molecule will have no overall charge. It'll be electrically neutral.